on VR in construction?
Hi, I'm Patricia. So this came about because I was asked to teach a new module. In civil engineering, we had to start to teach construction management. We were required to do this by our accrediting body, and also our industrial partners really wanted to see this topic covered. However, we struggled with it because we don't have any people who have significant site experience or construction experience within the college. So I partnered with Dornus, who are a local construction company, and we co-taught this module together. So I was doing the pedagogy around it. The content was really driven by the contractors and the consultants who were involved in teaching on the course. So a lot of credit on this goes to Dornus and Russell Evans in particular from Dornus. Civil engineering, a lot of people don't know what it is really, so it is everything you see around us. So all the buildings, bridges, water infrastructure, the physical fabric of the world that we engage in that is static, it tends to come under civil engineering. So we are very, very broad, and this is one of the problems with delivering this module. We have very wide expertise, but when we don't fit a particular niche, we have to go outside and we partner with others to do that. However, a lot of employers are getting increasingly dissatisfied with engineering graduates, not just civil. This is general engineering, not just Swansea. This is UK, this is international. The same is being said in the US and much of Europe as well. Now, higher education has expanded in recent years, so we're taking on many more students, but that's not the only issue. Because engineering is such a physical, vocational topic, it requires a sense of spatial understanding, it requires a sense of engaging with different disciplines, and it's very physical, it's very spatial. Most engineering education is still in spaces like this, it's in lecture theatres. So we teach mechanics, we teach maths, we teach construction management, for example, tends to be done in a lecture theatre environment where you are hearing the information and you're trying to engage with that. When it comes to design, we are asking our students to design in a PC room or in an open space around a table with a group with maps and plans, and we're asking to design large buildings. They can't easily get onto site to see these processes because the numbers are so vast. We have 155 students at the minute in year 3, just graduated, and those numbers are not practical to get them good experiences on site. Again, many UK civil academics have limited or no industrial experience, and this is one of the outcomes of the REF agenda, and the focus on research, and the lack of focus on teaching and practical skills, which has impacted those vocational subjects, such as engineering, possibly more than other departments. And then, once you move into the career space, you tend to find increasingly that designers who design the buildings and contractors who construct them and build them have very separate siloed career paths and very different cultures. You don't get much integration. All of this is leading to a problem at all stages, not just at university, but also I've seen it happen in industry, where the theory and the design and the paper exercise is not being translated effectively or well into the built environment, and there's a lot of conflict, a lot of money lost trying to resolve that conflict when it comes to the work. But when it comes to learning, it's this disconnect between theory and practice. And this is where I thought maybe VR could come in, because it could allow us to give our students a little bit more of a sense of what it's really like out there and get them to understand the spatial context of what they're doing, not just treat it as a paper-based exercise with a set of parameters to solve. So they can start to engage with the real question of what they're doing. This is supported by a number of, you'll find it all over the research, there's a lot of the same messages coming across. The students are not equipped. Vocational disciplines arguably require alternative pedagogies for employability, and that sums up for me a big struggle I've had since coming into education about how to bring in that relevance and that skill development, which you can't necessarily do easily in a lecture-based environment, a traditional education environment. Engineering students are graduating with skills more suited to a career in research than industry. It's the same messages we're getting. it's a big topic, so I wanted to focus down to something that I felt that I could start to look at and start to engage with and understand. I've always suspected the students didn't understand the scale of what they're designing. I just had the sense they didn't get the physical sense of the calculations they were making, the volumes, the depths, the dimensions. And I thought VR would give me an opportunity to test that. So that's what I did with this module. I wanted to know if they understood what they were designing. So if they draw a 10-meter road, middle road, do they have a sense of what that 10 meters looks like? So when they're designing and they're drawing it on the paper, are they putting themselves into that environment and thinking, if I stand here, it'll end where I can see it, and I understand that. So the design, this is a compulsory module in engineering. 155 students enrolled, it is a large number. And as part of one of the assessments, a very small assessment, they have to design an excavation. So it's 20 meters long, 10 meters wide, 7 meters deep. So 7 meters is pretty substantial. It's probably from here to nearly the top of the screen there. So if you're sitting in the bottom of that excavation, you're surrounded by earth, surrounded by large machinery. It's quite an intense experience for someone who's not used to that environment. And yet what we find is that in education, but also in industry, designers are designing these excavations without understanding what it feels like to be a worker in that environment and having to negotiate quite a complex, quite a dangerous environment, obviously because earth can collapse. So you wouldn't just dig straight down in this situation unless you had a particularly rigid soil. You would try and batter back the sides, or you would put steps in so that there's no danger of that earth collapsing in and crushing anybody or things. So this assessment was to design this large excavation. They did this over about 2 weeks. It was fairly complicated. It was more complex than that, but the core of it was this large excavation, trying to work out how to build it. So they did 2 weeks of this, and then after they designed it, they'd handed the plans in, they'd submitted their work, we gave them a VR experience of the actual site to test whether they could relate what they'd done to what it actually feels like to stand in the middle of that big trench. So this is all based around one of Dornus's sites in London. They were redeveloping Grasshoppers Rugby Club in London. They gave us some modified site plans and this big rainwater harvesting tank, which was going to go into this excavation. So big old 20-meter tank, 7 meters underground. Once they had designed it, then they had to go into the VR experience. And what we were looking for, we wanted to see if there was any surprise, or they could relate it straight away, or if the experience of seeing it in VR shifted their perception of what they'd done. That was the test, really. To give you an idea, there's a lot of numbers involved. So the whole exercise is based on spatial awareness. It is based on understanding how far a digger can dig down. So this example, this back actor can dig 4.5 meters down. 4.5 meters will not reach the depth of 7 meters that you need, so you have to think about this in a staged way. So you can dig one layer, you have to step down with the digger, dig the next layer. Little things like that. So it's a 3D shifting exercise. They're also working in quite a constrained space, so they have to think carefully about where the digger can move, what is the range of movement, what's the corridor that it can move in, how can it turn, where does it go? And it's like a 3D puzzle, you know, that we normally ask them to do in 2D. So they're working in a piece of paper, they're working in a group around a table with this information, and they're trying to do a 3D jigsaw puzzle, effectively, to work out where to put the machines at each point in time, which part to dig out first, where to move the different machines. Similarly, the crane is also a really large piece of equipment and really unwieldy. For the crane to be deployed, you have to have outriggers, which you can see coming out the side. That's a plan view of the crane down onto the crane in the bottom corner here. And the outriggers then give that crane stability. What you can see here is a diagram that tells you how much weight the crane can lift at every angle of deployment. So clearly, when you've only got a very small angle of deployment, that crane can lift a huge amount. but it can't lift it very far away from where the crane is sitting. If you want to extend much further, the weight capacity of that crane reduces dramatically. So again, it's another spatial, tricky question for them to engage with. And all the time, they're thinking about distances and relational space between these exercises. So the final bit, then you would put the tank in, put some more earth on, and you would have to compact that earth. If you're not compacting the earth as you put it in, you risk subsidence later on. So it's quite a long process to get this big hole all filled up. Now what we found, and this didn't surprise me, the student groups are really struggling to do this 3D puzzle in 2D. And quite frequently, they would design the trench excavation so that they backed the digger into a corner where it couldn't get out. And it couldn't reach the dump truck to reduce the load. So they were just missing pieces of the puzzle. They were struggling to juggle all the balls in the air and make sure that they were thinking about every single piece of equipment at that time. When we showed them the VR, the students with sight experience were less surprised. So those students with sight experience clearly have an understanding of scale. The interviews, we conducted 4 recorded interviews. We observed 15 students. We conducted 4 interviews. All 4 interviews, the students mentioned the VR improved the context for the assessment. All students who tried the VR were surprised. We saw them being surprised. And they were saying, oh, wow, I didn't realize it was that big. Oh, my gosh. You know, that those sort of responses are really common amongst the students. I wish we'd captured that. We didn't capture that. We only captured the recording, the recorded interview information, which was really helpful. And as an example, so one question was, how does the case in the second scenario align with your predictions? And one student was saying, our method is slightly different. So once I visualize it now, I realize it's much bigger than what I anticipate it to be. When you draw it on a map, you don't feel how deep it is. You don't get an actual realistic feel. It was actually bigger than I thought it would be. How does it affect your understanding of the task? And it's the realism element. It's proportional. So I actually think universities got a bit lazy, especially in engineering. So if you want to become a professional engineer, you have to get a degree. And universities have had a captive market for this for God knows how long. And that monopoly has led to complacency. I do think apprenticeships which are coming in are a serious threat to a lot of engineering education because they already combine this realism and theory. They're linking theory and practice straight away. I don't think we've got a choice but to go along this route where we can try and bring in more realism, more theory linked with practice for improved learning gain, improved learning benefit. Because otherwise, how are the students who are educated within the university going to be able to compete with apprenticeship students who have that benefit of learning gain from applying? So VR becomes quite useful and quite powerful, possibly in allowing us to try and bridge that gap. I'm actually nearly done. We're going to finish early. So, caveat, this study compared 2D drawings, but not 3D imaging software, which does have spatial element. So that might be affecting. It was a small study. There were 15 students who experienced the VR, and there were 4 who recorded interviews with. The implications are that even though students are engaged in spatial reasoning, and they did this for 3 years, these are third-year students who've been designing a lot of things. And it was quite upsetting to know that the students, so many students who'd been designing things for 3 years, didn't understand the scale of what they were designing. They hadn't got that appreciation of what it would actually look like. And that is a risk in construction. Construction is very dangerous. It's one of the most dangerous professions globally because clearly you're working with big materials, tight timescales, big machines. If you are designing something without due regard to the the risk that you are putting people in that environment, you're not doing your job, because you are putting people at risk, and you may be unwittingly causing accidents on site by not fully considering all of the spatial issues of your design, I guess. So possibly VR could help to bridge this divide if we combine it with active problem-based learning. And a lot of the majority of the module I delivered was active problem-based learning. I've very much moved away from lectures. I now tend to have group tasks and do learning through task-based work. This is one. I want to build on this next year, possibly. So this was a jetty for Hinkley Point C in Bristol. And the jetty's being constructed because Hinkley Point C is a big nuclear power station. It is a huge amount of concrete required to build that. The roads around Hinkley are very small, and they didn't want to bring the aggregate and the stones and the material for the concrete over land because it would disturb the villagers too much in the surrounding area. So they built a jetty, and they're shipping in all of the material for construction via this jetty. And the students had to design this jetty this year. So what I did this year, it was a day-long game. It was a simulation exercise. About 6 hours, which was going to be condensed in we were going to try and simulate 1 year of project programming over 6 hours. The students worked in teams. They had pieces of information. So they knew how much the boats cost. They knew how much the piles cost. And they knew how long every process took, but they had to put it together, jigsaw it together, to understand how to program that piece of work. Budgeting it as well. And then throughout the day, we assigned different incidents. So we said maybe strike action. So the workers have gone off site. How does that affect your program and your costs? Or there was a fatality. So how does that affect work on site? This is really where I want to go. So if we could go into more of a simulation environment where they are having to deal with these more complex issues, but they're actually in the space and they can control the space. And when an incident occurs, they are able to choose different actions with different consequences. Active project management. I do think project management is something that is very difficult to teach. It has to be experienced because it is the complexity of different priorities, different people, personalities. And bringing that together in a VR environment could be quite powerful. So that's the next stage. Clearly, I'm not there yet. Yeah. So that's it. The big question still is this scale issue. It's how we can relate the classroom-based work to the real environment. And that's kind of where my interest lies at the minute. And I'd be happy for any questions.
Thank you, Patricia. I have a question. Can you just explain to us how the VR was facilitated? How did you use it?
Oh, sure. Sorry, Google Cardboard. So it was Google Cardboard. The question was, because you got the mic. The question was, how was the VR facilitated? So it was Google Cardboard. The students had a Google Cardboard device, and they put their phones and downloaded an app, and we gave them a phone where they could look and they could go into the VR environment. So the VR tour actually went right down into the excavation. I went onto site earlier in the year. I took a 360 sphere and took 360 photos of around the excavation. I went in the excavation. I took some videos of the digger digging. So all of that is what they experienced within the Google Cardboard tour. They could navigate it themselves. They could go and look at different parts of it.
At the moment, do any of your students, as part of your course, design any of their projects and their models in such a way that they can actually export those drawings into a VR environment?
Yeah, and we have a talk on that later. There's a poster on that. There's a poster on that. So if you want to talk about, yeah, we do. But it was Claire and Ping.
One project where they create 3D models using Revit. That's been something they've done for a couple of years. It's sort of an extension of what they used to do with AutoCAD. Now we've got 3D, and this year we put that into making VR models that they interact with
Mm.
So I was wondering, again with a sort of gaming type idea, would it be advantageous for students to be able to drive the digger and dig the hole themselves and use that sort of?
Yeah, ideally. So the question was, could the students drive the digger themselves and do the excavation themselves? Yeah, that's what I want.
Apps where if there's those sorts of apps that are already available.
There are some really good apps. There's none that do everything that I want it to do. So there's a really good project management app out there, which you have to build 3 different houses at the same time, but you've got limited resources. And so depending on where you deploy your different construction teams, your costs go up or down, which is it's a really nice little app.
In VR, is it?
Yeah. And then you've also got simulation apps, but you haven't got them combined. I think from my point of view, I'm more interested in this. I want them to juggle. I want them to juggle and struggle. So very much like the presentation done in the last session, if you were in this room, where they're working in a team, but they had information to manage between the team. Not everyone had the same information. They had to communicate, and it would be something. Trying to draw those skills out. Yeah.
So you said you use 360 video. The question is, did you consider doing a augmented reality now? So all the extra information on the video in order to things like fluids and spatial perception? Because it gives students information, right?
So having the plan and then having the AR coming through the phone, looking at the plans, is that what you mean?
Stuff like you could put an angle of the back actors,
Yeah,
what in terms of the rig. Would that have helped? Or?
definitely, yeah. I think there's lots of possibilities. This is baby steps at the minute. I'm kind of exploring it. And when it comes to the pedagogy, again, that's something that I'm learning about. What I wanted to do this year is just work out is it just novelty or is it benefit, you know? So I wanted to start off by answering that before going into lots of different options. So, and for me, I've answered that, I think, for me, having seen the reactions and seen the fact that there is an issue there and there's a clear learning objective there, because if the students are no longer surprised by that, tick, you know? They do have spatial understanding of what they're doing. They don't now. But I think AI would be really powerful. And probably more accessible because you're not limited to using the headsets. So.
One of the issues with passive learning, don't actually want it themselves, but have to direct it.
Yeah.
Is your hope in exploring this with students that it reaches a parity of awe and wonder? Because if you're honest, civil buildings, certainly if I see a big digger,
I get excited. Yeah.
you can't, you actually gauge the kind of scale of those things relative to yourself and smell and everything like that. Is your hope for this that somehow be equal to that experience?
No. So the question was, can VR be equal to being on a site? And no. If I had my choice and lots of time and budget, I would put every student on site for 6 months. But that's not practical. Partly because some of our students have got so far to go, and I wouldn't be happy with their safety on a site. They would need supervision. But this sort of thing could give them the experience to get them to that stage of being safe on site, possibly. Yeah. But you're right, I mean, so the sound and the smell you just mentioned there, you're not getting that full sensory overload, and you're not getting, it's not active environment as such.
Sorry, that gentleman had a question.
Oh, sorry.
It was just more about partners' dorms. Did you get any feedback from them, from the students' designs? Did you show them designs and dorms and this would be an issue? Did they feed that back to the students?
So I sent all the assessments to Dornus. They gave me feedback, which I gave to the students. I think it would have been lovely to have a session to do that face-to-face with the students. But he picked up on a lot of the issues about spatial awareness, so they just hadn't thought about how can the digger exit, how can the roller get into the excavation, where's the dump truck going to, because the spoil heap wasn't by the excavation, so the dump truck had to get to the digger and then go back and forth all day. And then they blocked off the route and hadn't realised they'd blocked off the route. I can't think of another way of doing that other than VR, personally, because obviously real, or little models, play with little toy dump trucks and things on a table, which actually might form part of it in the future. It's the first year the module ran, so it's a bit of an experiment. Dornus wanted this exercise in. So they're saying that our graduates are not comfortable with dealing with these issues. So the exercise was designed to fill the employer gap, skill gap that they've perceived. So they have their own internal training course. They send all their graduates on another internal training course to teach them what they really want them to know. Dornus want to work with us so that we can start to put those into our programs so they don't have to do this extra training. It's kind of where we are.
Any other questions? Great. Thank you, Patricia, for
Thank
sharing
you.
that insightful experience. So now that's the end of the session before